The dawn of the nuclear age spawned a new kind of matter, and scientists just discovered a piece of it. When the world's first nuclear weapon exploded on July 16, 1945 in the desert outside Alamogordo, New Mexico, it vaporized the test tower that had held the bomb, blasted a 80-meter-wide crater in the desert floor, and fused the sand into a layer of glass 2 centimeters thick for 300 meters in every direction. The world had never seen so much destructive power. And 75 years later, we're still finding surprises amid the debris of that first nuclear blast, the Trinity test. When the bomb exploded, its fireball swept up nearby sand and fused it into lumps of glass and crusty fused material, which then rained down from the sky. Most of that clumpy, part glass and part crust stuff is pale green, and it's been nicknamed trinitite, in honor of the nuclear test that created it. Some trinitite, however, includes bits of the test tower or the copper cables that once connected cameras and microphones set to watch the explosion. All that copper tinted the resulting glassy substance red. And a recent study of a sample of red trinitite reveals that not only did the force of the world's first nuclear blast melt sand into glass and vaporize human-made metals, it warped and fused those materials into a strange crystal that breaks some of the usual rules of how crystals are supposed to work. The strange byproduct of CataclysmCrystals, from snowflakes to table salt to diamonds, are all about order and symmetry. They form because atoms arrange themselves in a 3D pattern that repeats over and over. Each repetition of that pattern is called a cell, and the cells that make up each crystal have to fit together so neatly that there are no gaps between the edge of one cell and the next. That need for extreme order limits the number of possible ways a crystal's lattice of atomic cells can organize themselves. To describe that properly, we need to think about symmetry for a minute. Imagine a shape. Maybe it's a square, a 5-pointed star, or a large X. How many ways can you divide that shape and still get identical pieces? If the answer is 3, which is what you'd get with an equilateral triangle, then the object has threefold symmetry. If it's 6, as in the case of a Star of David, the object has six-fold symmetry. Of course, anything that has six-fold symmetry also has threefold symmetry and two-fold symmetry. A normal crystal, what physicists call a periodic crystal, might have 2, 3, 4, or 6-fold symmetry. But some kinds of symmetry, like 5-fold and 7-fold, are totally out of the question. It simply isn't done. But under the right circumstances, by which I mean genuinely terrifying amounts of sudden heat and pressure, atoms can be forced to line up in unusual ways, creating something that's technically a crystal, but breaks those rules of symmetry. They're called quasicrystals, and so far scientists only know of about 100 of them.